Okay, it is now time to venture out into JavaScript land. The course is primarily HTML and CSS. However, it's not a bad idea to be able to mix in a little JavaScript in because you know, chances are you're going to have to use JavaScript from one time or another, especially if you're working with forms or if you're doing something else. And JavaScript is probably going to be the easiest scripting language to learn and to use. And it doesn't take much. In fact, what I'm going to do is go through the entire language today and probably finish it up next week if I don't finish this. But this is lecture number 9, I believe. I'm skipping 8. I'm going to go back to 8 after I finish 9. Because 8 has a bunch of examples with HTML and stuff, and it puts it all together. But this is the core. It's about 168 slides. It goes real quickly, though. That was one of them. So we're on slide number 2 already. So it'll go pretty quickly, though. So what are we looking at? Let me just give you a little background on what this is and why you want to learn it. JavaScript capabilities adds content to the web page dynamically. So HTML, CSS, it's all static. In fact, you can't make very much changing behavior. I mean, you can scroll stuff across the screen or something, but you can't really do anything functionality-wise until you venture out into a scripting language. And most pages have a little bit of JavaScript, even if they're using something else. So JavaScript can be used with other scripting languages and with other technologies. And it basically allows the web page to respond to user events, essentially, which is what we're interested in, why we want to actually look at this. And it reacts to user events, interacts with frames as well, and manipulates HTTP cookies. Probably going to skip the cookie stuff because it doesn't work anymore. Most web browsers have disabled everything associated with cookies. JavaScript is not Java, so if you're a Java programmer, been doing it for years, you still have to learn JavaScript. It's totally different. Although it's kind of similar, it's completely different as a language. It's very simple. It's considered a scripting language. It's also considered a subset of Java. So some of the syntax is the same, which is why it's kind of, in fact, some of the syntax is the same as C++ too, which makes it, and C, and some other languages you may have used, which makes it an easy language to pick up. It's an interpreted language. It's read by the web browser on the client's computer. It does not run on the server. It's a total client-side scripting language, so it can't be used for secure applications. It can't be used for storing passwords and things to log on to servers and stuff. Not a good reason. A good use of that. Believe it or not, it uses objects, but doesn't really support object orientation or the creation of new object types. But you can create objects. You just can't create your own user-defined object types. And I'll get into that a little bit later when we start looking at it. Here are some of the elements. We have variables, literals, operators, control structures, and objects. So if you take away anything from today, learn that JavaScript is an object-oriented programming language. It is, actually. Except for it does not have full support of object orientation. But it does a lot, and we'll see that today. So here are some basics. In fact, we may have actually gone through this already. We looked at the document.write at one point. But what we're doing is creating a script now. And we're saying in the header, script language is going to equal to JavaScript. And in the lecture 8, I'm going to show you how to put it together with an HTML document. Today, it's just all about JavaScript. And then we'll put the pieces together next week. So document.write hello world, there's hello world in JavaScript. And it's basically saying that the scripting languages, it doesn't mean you can't use another scripting language in there as well. So when you put these commands inside of the script container, and the write command, or the write method, I should say, write is a method that's of the document object. So right from the get-go, from the hello world, you're using object orientation because you're running a method write from the object document. And you don't really have to understand what this is, actually. You don't really have to know what an object is either to understand the concept. So this basically allows hello world to appear on the screen. And so you can put the JavaScript in either the head or the body of the document. It does not require just to be in the head. Even with a write command in the head of the document, the text will still appear in the body command as well. So if you do put it all in the head, it'll appear in the body of the document, even though some of the other items that appear in the head section don't appear in the body, like, you know, as an example, the title of the web page and stuff like that. So embedding HTML into the JavaScript output. This is kind of an interesting little thing. So you can put as much or as little HTML as you want inside of JavaScript. And in fact, you can write the entire HTML document in JavaScript. All you have to do is do a document write and then put your tags and put your information out on the screen. And if you don't even, I mean, it's harder to do that. I would just rather use HTML if that's the case. But HTML you can put inside the JavaScript. Choose to mark up the document that you're creating while you're working with JavaScript. You must use a print. So in order to get the HTML elements to actually show up as HTML elements, you can't just put them around the HTML commands. And here's an example of what this is talking about. So what we're taking is the inside the write command we're writing out, and we actually have to use quotes on this as well. We're putting in a bold hello world and then a closing tag for bold. This is standard HTML that we're putting inside of a document.write. We're doing that inside of maybe a JavaScript function or something that we're writing, which is interesting. You can't do this though. You can't go like bold outside document write, because a lot of students would try to do this first. Because they're thinking, well, why do I have to use JavaScript? It's HTML. But if you're in JavaScript and you're writing JavaScript as a function, in a little section maybe in the header, or you're writing a script in the header, or you're writing it in the body, you've got to embed the HTML tags in document write commands. So let's take a look at some more of the basics. Although we have multiple write commands might be used, HTML will still ignore the different lines and put the words all together. Which it says is following the same standard as HTML. So if you write out an HTML document, hopefully you know this by now, you press return and you go down to the next line and you write another line and press return. It doesn't read any of those returns. You have to put your own line breaks in. Same concept with the JavaScript. You have to put your own line returns, new line characters, your BR, line break, or your new paragraphs. Otherwise, it's all going to end up on one line. So if you want to force a new line, you use the BR for line break. If you want a new paragraph, use the P. So here's an example where we have hello, printed to the screen, how are you? This is going to be right next to each other. So there's no line break, there's nothing. It's going to appear actually, concatenated together. So it'll appear on one line. If you want it to appear on different lines, you can put the line break in here. So that's common that most people would, not think about until they ran into it and went, how come that looks like that? So let's get into variables in programming, and this is really not that bad. Actually, most of you who've taken Java or anything, this is not bad. This is easy. So that's why I can teach you entire JavaScript in one lecture, probably. So a variable, it's a name storage spot. Same concept as in Java and C++. Stores the information. It's kind of like a box where you can put temporary information in there, store it for later. Variables are often useful for programming. Allows you to retrieve information. Prompting for and storing user input. Most of you will use this technique, especially with the password. There's one that does a password checker. There's an assignment that does, probably should have gone through the assignment. I'll do the assignments later. Password checking one, and there's one that does like maybe a translation or something. I'm not quite sure. No, grade. Entering GPAs and getting, what was the other one? Talk like a parrot? No. Yeah. Did I do talk like a parrot? Oh, I like that one. Where you type the stuff in one box, and you press a button, and it goes to the other box. JavaScript, right there. And it's not actually that hard. Most of you kind of looked at those assignments already, probably freaked out on it, maybe. I don't know. Went, oh my god, this is a programming assignment. Nah, it's not really that bad. It's actually not too bad. And you can also cut and paste code you find on the internet for this as well. I'm not grading you on your abilities to learn a programming language. It's not a programming language course. So if you find something that's useful, go ahead and reuse it. Obviously, don't reuse your neighbor's program. But I'm talking about like a function, or I'm talking about like some sample JavaScript code you might find in a book, on a website, in an example, in one of my lectures or something. So you can go ahead and reuse that. We all know about the prompt. We've seen it already. This is like one of the first things you learn when you start learning JavaScript. So in order to prompt the user for information, you have to use the prompt. You can store the results of the prompt in a variable. So you usually this variable is going to be equal to this prompt. And so you enter the user's information, the user enters the information, then it's stored in the variable for future use.
And we'll see some examples of that coming up. So in order, prompting and storing, the order and how we do this is important. We actually have to declare the variable first. So first we create the variable, and here we have, this is an example of how to create a variable. And just like any other programming language, there's a semicolon that appears at the end of each statement. So here's where variable tells us that it's going to be a variable and the name's going to be name. And the name is the variable, so it's now going to use this computer spot and call it name. It doesn't really use memory. Actually, this is all controlled by the browser, believe it or not. And here's our thing where we go, name is equal to prompt, enter your name. We actually saw this in an example already. In fact, you've seen some JavaScript already in a couple of the lectures I've done. So once we have declared the variable, we assign it the value of this prompt. So it takes the information that the user types in and assigns it to the variable. So you could do this for the GPA program if you've started working on that. So hey, enter the first one, enter the second one, enter the third one, enter the fourth one. Or enter in all of your GPAs separated by a comma, and then you could use a split on it. And a split was actually one of the lectures I've covered already, I believe. No, it's coming up tomorrow, coming up next week. And that actually just splits it all up and puts it in an array for you. So you see, like, a lot of the things are automated, and not so bad actually. So using the variable to retrieve the information here, we can just write it. Notice we called this a VAR variable. And for those people who know something about different languages are wondering, what in the world? No data type? Nope, no data type. It's a variable data type, which means it can store a number, it can store a character, it can store anything you want. So it's just a variable. And that's the data type. Actually, we're creating a stored memory space called name. That's a variable data type. And now we're just going to print name to the screen. Notice we don't have any quotes. If we put quotes in here, we'd be printing the word name to the screen. So when we want to use the variable, leave out the quotes. And then you're going to print the value of name to the screen. So here's an example. And you can cut and paste this and put it in a blank document if you want to, actually. I put in the HTML opening and closing tags, the head opening and closing, or the body opening and closing, just to make sure your browser can read it. But I would almost venture to say you could probably cut and paste this, put it into a text file, double click on it, and it'll probably load up just fine. So, script language JavaScript, variable name, name is equal to prompt, enter your name, write it out, hello, name, and then end. So that's a hello world with I/O. More prompting. Let's ask then the prompt function. Also, there's a default information into the field that you can put in there. So if you do this, you can say default text and put the default text in there so that, like, type your name here. Actually, it's kind of like instructions that you can give to the user. So the default text will appear in the editable area, so the user would have to back. Some people find it that irritating, actually. The box comes up and it's not blank; it's got something written there. You got to backspace over what's there to put in something new. So I don't know. You can put something there if you want to, though. Just like any of the other HTML tags. Multiple variables. So you can use multiple variables when using JavaScript. It means you're able to handle multiple different types of inputs from users, and you can access them in different variables any way that you wish. It's important to point out that a variable can be used many times as needed. There's no lifespan. It's the life of the program, I should say. There's no limited scope. It's global scope. So you can declare multiple variables in two different ways. You can say one per line, or you can put them all on the same line. Yeah, people know programming go, yeah. Except for the data types, it looks like C or C++, C or Java, actually. You separate the variables by a comma. So it's common to see one line with variables and all the variables that you're going to use. You can retrieve multiple pieces of data. Here we have first name is prompt, first name, last name. And this is what's going to appear as the default text, actually. And then write the first name and then put a little space in there and write the last name. So variable naming, just a few rules on that. You can assign different names to different variables, helps keep you track of the stored memory that you're using. It's important to choose appropriate names, keep track of them. A few naming rules need to be followed. Names can be composed of letters, numbers, and underscores. That sounds familiar, just like C, C++, Java. So there's standard naming conventions that you're probably familiar with if you know any other languages. Names cannot have spaces, obviously, or special characters. They can't start with a number. Well, that's a C++, C, Java rule as well. You can't start a variable with a number. Names are also case sensitive. Also the case in most of the languages you probably are familiar with already as well. Here's some examples of some variable names. Wait a minute. Names cannot start with a number. Here we have one with a number. Huh. Scratch this one with a number on here. That's not legal. I was looking at this like, oh, there's something wrong with that. But anyway, here's some examples. This one here, scratch off your list. In fact, scratch this one off too. Those last two of them aren't gonna work out right. So they're illegal. Storing strings. So we have strings that are words of variables, such as the first name, the last name. What we've seen so far, we've created a variable name, first name, last name. So the pieces of information that with characters, refer to them as collection of characters or strings. And a string is a collection of characters that you can find on the keyboard normally. And they're stored the same way, actually. Collection of characters as there are characters. You can also store numbers in the variables. Numbers tell the computer what data to be stored, essentially. Number is not a string. It can be used as a number. So it'll read the variable will actually read the type of information that's being assigned to it and treat it as a number or treat it as a string. You don't have to tell the computer what you have a number. It will treat the digits like a string, actually, if you're going to print it out to the screen or something of that nature. So let's look at some examples, put this in perspective. We have, in order to help us understand the differences between the string value and the numeric values, you're going to show our strings surrounded by quotes. So here we have number 45. That's going to be treated as a string of 2 digits, 2 characters, because we have quotes around it. And then we have number 45. That's an integer 45, because we don't use quotes. So they're often they're used to represent. In fact, some languages actually, some web browsers don't require the quotes. Probably not a bad habit though to get into, because it makes your code a little bit more readable. Especially if you have a number, you're going to store it as a string to use the quotes, because then when you look at the JavaScript code, you can go, that's supposed to be a string. It's got quotes around it. So in terms of reading input, we can prompt the user from the user, stored as a string. Some math operations might not work with variables, but not all of them. So when in doubt, the computer will treat the input as a string. So the default value is actually a string for each one of the variables that you're going to assign. But you can convert the strings to numeric values. We can say, we have 2 different types of numbers that we might use, floats and integers. There's not a full, like in Java, let's say, or C++, there's not a full variable support. We don't have like the shorts, the longs, the wides, the narrow character. We don't have any of those special ones. We have floats, integers. Float's a number with a decimal point, for money, stuff like that. Integer's a number without, so it's a decimal point, one whole integer value. And if you want to convert a string to a number, you have to decide which numeric type you're going to convert it to. In terms of floats, what we're doing is treating the variable, because variables come in as strings, and by default they end up being strings. So we parse the string to a float, or we parse the string to an integer. You're going to need this for your GPA calculation. Otherwise, if you take adding up the strings, you're going to concatenate the strings instead of adding up the GPAs as numbers. So in order to convert the string to a float, you would use the function parse float, where parse is going to be the number of the string variable, and it removes the number from the string, storing it as a numeric value. So we'll remove the extra characters as well, and blank spaces that might be before or after, which is not bad. You don't have to trim it or do anything like that to it before you parse it. Just parse it. And it will not remove characters that appear before the first character. So let's take a look here. What do we got? Variable x, y, and answer. X is equal to prompt enter number. Then now x is going to be equal to parse float x. So now we turned x into a float.
If we had characters, let's say if we had like, you know, barb2, it's going to say barb2, but 2 is going to be a number. So it will actually take that preceding information, which is kind of confusing, which is why you probably want to separate it out like this. Say enter a number, take the number, parse it to a number. Y, enter a second number, parse float y, and then answer is going to be x plus y. I've actually seen people do parse float and then inside prompt enter a second number. You can actually mix these two statements together if you wanted to. Because what the key is this parse float. So instead of taking x, you could probably just stick this in here, is what I'm saying. And then shorten your code down. Makes it less readable, especially to new people, but it will condense your code a little bit if you wanted to. And so now I'm going to write out to the screen x plus y is equal to answer, because answer is equal to x plus y. It's going to add it up for us. So you're going to have to do something like this for the GPA calculation, actually. So when you use a variable stored in x and y to create a new answer, it's going to be stored in answer. Use the 3 variables again to write the information onto the screen. When you're using write command, you have the option of including multiple items. So you can write out floats, doubles, strings all at one time, and include the appropriate spacing to make the output look good. And here's an example of that, putting in the space before and after the plus. But the interesting thing then, I didn't point out just as a note, is x can still be used even though it's parsed. We're parsing x to x. We're still using the variable x. We didn't create, because I'll see students like create multiple variables, like x1, x2. Take x1 in as a number, print it out. X2 is going to be equal to float x1, and copying it from one to another. You don't actually have to do that. You can still use it, even though you're parsing it. You're taking x and you're just going to equal a parse float x. You can still use x, because it doesn't really matter. Down here you can actually still use x and print the value out as a string, and then use it as a number as well. So that was a little side note I thought I'd mention. What about ints? It's the same way. An integer can be stored from a string. We parse int function, and the function will retrieve an integer that is entered in by the text. So from the text, if there's an integer in there, it'll parse it out. So as the parse float function, trailing letters will be removed. Trailing letters, leading letters will cause an error because it wouldn't know what to do with it. So parse int will also remove anything to the right of the decimal point. So if you have 4.3f as a value that's stored into the prompt, and will be stored into the variable, so part int will make that into, will end up with a variable value. Part float will end up with a variable value of 4.3. Part int is going to end up with 4, because it's going to take off that trailing number. Doesn't do any rounding or anything. It just takes the integer value, which is interesting. And it ignores the trailing characters. And you wonder why we want that. Because sometimes this information comes from all different sorts of formats. You might be reading in somebody's source code. You might be reading from a file or something. And you might have these little strange end-of-line characters or something. And so it's nice, it just ignores it. You don't have to trim it, get rid of the characters, and then parse the integer. So it's more automated than you'd actually expect, which is good. So what about other math calculations? Subtraction, division, multiplication, everything works. Like any other programming language, it supports most functions. So use these functions to basic math. So, you're going to have to add up all your GPAs and divide by the number of GPAs to see whether they're entered in. So it's not too bad. Actually, on that GPA program, you can just fix it. Enter in 10 GPAs. Okay. And then divide by 10. 5 GPAs or something, to make it easier for yourself. So what about strings? You can perform math operations on variables that are numbers. But do these same operations work on strings? Do any of the math operations work with strings? Good question. If the math operations don't work on the string, the results will tell us that we have an error. Well, no. Yes, no. It'll say not a value. It'll come out with a problem. So this is an interesting phenomena that will happen. The math operations do work to answer those questions. However, they don't do anything that you'd think they would do in terms of numbers. The plus will concatenate the two strings together. So if you don't have integers or floats and you're working at strings, if X was Bob and Y was Bill, you got Bob, Bill concatenated together. The minus, the multiplication, the divide will all fail. The results on the screen is you're going to get NaN, not a number. So it stands for not a number. As a result of the equation, it is not a valid number. It's not an error message, it's just telling you it's not a number. So if you've taken minus x from y or something, it's not going to recognize it as a number. Which basically, if you ever see this coming out as a result, you have a string. You're doing something with a string and a number, or two strings, but there's a string involved. So all you have to do is parse int or parse float that string to a number, and it'll come out as a number instead of not a number, essentially. So errors will give us errors if we try to do something that it doesn't like. Unlike HTML, which doesn't do anything, it just won't print anything to the screen, JavaScript will actually give you an error message, which is kind of nice. The errors will involve something printed to the screen, or might involve nothing printed to the screen, might just fail completely. And we'll need to be able to figure out where the errors are and fix them. Personal suggestion, write your JavaScript in fairly small logical sections. Actually, use functions whenever possible. And then test the functions, make sure the functions work. So test each section to make sure that it all works. Once one section works, move to the next one, and then start building on it section by section or function by function. So if an error is introduced, you'll be able to know where in the code was caused. And put all the JavaScript together, actually. A lot of people like to scatter it out all over the place. You know, if I'm going to create 5 functions, I'm probably going to do it in the, in the head section. Or I'm going to do it in a separate file. And I'm going to use the file in there. It's the same as using a CSS file, actually. And I'm just going to have them all together. Sometimes I look at these websites and they have like, oh look, down here there's a JavaScript function right before it needs to be used. Somebody decided to put a function down, because you can put this in the body, no problem. And then the function is being used, and then further down the road you see another function, but that's not being used. But it's just weird, just scattered. It's like taking and declaring your variables all over the place in your source code. It's like, well, why do we have that? So if you're unsure about how a piece of code works, you can look it up online, make a small program, see how it works. That's why I say go out online and check out some of the JavaScript examples when you're putting together these projects or assignments. So by writing the code, you're going to see how it works. You're going to answer your own questions, hopefully. It's a great way of learning, actually. It's by example. Error types. There are 3 different types of errors that might exist. You've got syntax errors, where you just wrote something wrong. Logical errors, where it's logically impossible sometimes. If it wasn't impossible, it would actually work. Maybe a loop that just goes around and around and around and never takes you anywhere. It's kind of the same logical errors that happen in regular old programming. And then user errors. You asked for a number, they gave you a character or a string. And if you asked for a number and you didn't parse it, but you treated it as a number, it might actually work. But if the character gets entered in instead of a number and you didn't parse it to a number and you used it, you might come up with a weird error message. Probably going to get not a number showing up on that. So you must be able to determine the difference between the errors in order to be able to correct them sometimes. Not a must, but sometimes you do. So syntax error is incorrectly typing in JavaScript statements. If you type in here, it's a syntax error, you accidentally left out the end quote here. The missing quote will cause the statement to fail. Some statements may simply not work in some browsers as well, which is interesting. Not every browser is created equal, and they don't all have full JavaScript support. Some of them only have partial. Most of them do, at least 90% though. And here you're not going to get a message that says, quote missed or something. It's not like a programming language where it's going to come out with a nice friendly little error message. You left out the end quote. No. Well, thank you for telling me. And then you go in and fix it. No, instead, you're just going to have nothing show up on the page, or you're going to get a really weird error message. Something unrecognizable happens. Logical error occurs when you make mistakes in the logic of the statements. Do something different. Multiplication before addition and subtraction. You're going to get a different value. So it really means that the second number, we type in the first one, you're just going to have some sort of a logical error that occurs with that. And then user errors caused by users putting in the wrong information. So expect the user to enter in a number and enter in a character or something like that instead. So. And you can always double check to see what the user has typed in as well, helping to avoid this problem. And we'll learn more about this method later. Actually, maybe as soon as next week we'll go through what's called a form checker. I guess I've probably seen these already. If you've done any web development work, every single form has got a form checker. Because form checker is going to make sure that, was the first name a string? Was the telephone number a number? Was the birth date a date? Did they give you all parts of the telephone number? So if you check the form, I mean, you have good information, hopefully. Some people actually take that to an extreme, and they look up, like in an address database from like the United States Parcel Service. Is this a valid address? Or before they'll even continue, they'll send you an email to the email address that you entered in, and you'll have to click on it to validate your email or something like that. Writing readable code, just like in any other programming language. Once again, writing someone being able to read your code. Writing readable code is important. And you might be able to write your programs in a couple of different ways. So choose the best method, makes it the easiest, clearest as possible. Is a nice rule of thumb to keep in mind. In terms of variables and statements, you must declare your variables before you use them in the program. Same rule applies to other programming languages. It doesn't make any sense where you declare variables as long as they are declared before they are used. So it doesn't really matter where you declare them. So you're never going to see a JavaScript program, JavaScript, anything that has a bunch of variable initializations up front, or declarations. You're not going to see that. You're going to see them right before they're being used, or as they're being used, they're being declared. So to make the code more readable, you can declare all of your variables at the top of the program. I don't ever see that happening though, because that would mean you're actually going to, program. This is a scripting language. I mean, unless you're die-hard programmer, you're not going to probably put your variables up in front. But it does make sense for readability, which is that statement. In terms of the variables and statements, we have our program. If we have our variable declarations up front, we can have our program statements underneath. This is what you normally get taught in traditional programming courses. You always say, put your variables up front. and then actually I go take that a step further. Put your functions up front. Variables and functions all up front, and then some other miscellaneous code you've got down below. Or put everything in a function. Because if you think of JavaScript, what you're doing is you're creating functionality that you're going to use with the HTML. And it's not, your entire page isn't written in JavaScript. Or it could be. There's no reason why it can't be. But it's usually a combo of other technologies that are being used with it together. And you're using the JavaScript to run a function. Because you can't write a function in HTML. It doesn't work. But you can write a function, and you can call the function in HTML. And if you have a form, on the submit button, it goes and calls the form checker function. It goes through and checks all of your form elements and makes sure they're in the right format. So JavaScript variables are untyped, as we've seen so far. You can declare with the var keyword. Here we go. And then it can also be created automatically by assigning a value to them. So if you did this variable foo, and then underneath you said foo equals 1. Or you could just say foo is equal to 1 and skip this part. Which is interesting. It's not what I'd call, it's an untyped language. And because it doesn't have types, it makes an assumption. And it actually assumes that these are variables. Which is interesting. So we can create it automatically by assigning a value to them, blah. It's hi Dave. Using the variable to declare the variable results in a local variable inside a function. So you're inside of a function, you use var. If you don't use var, the variable is a global variable. So this answers the question, how do I create a global variable? You just start using it. Don't declare it. Just say foo is equal, this is a global variable. These both are global variables. Actually, this is not global because we made, this is a global, this is a local. Because we said variable foo is equal to 1. Maybe in the same program scope in the function. This one here is a global variable. You can use it anywhere inside and outside of functions. So if you're not familiar with the terminology for global, everything on the entire page. Which comes in handy because let's say you've got a function that uses a variable further down in another function, you're using the same variable. Then you don't have to pass it back and forth. It just changes. So you don't have to pass variables all over the place. They're actually kind of treated like pointers if you think of it that way. But I don't want to confuse you with the word pointer. So sorry I said that, actually. Pointers aren't good. I mean, for students. Literals. Typical bunch. Numbers, strings, booleans. Let's talk about arrays. Arrays can hold anything. It can hold numbers, and it can hold strings all together. So it breaks the rules. Well, we've broken the rules a couple of times already in terms of Java and also C++ or C. Mixed matched variable types inside of an array. Can't do that in most other languages, but you can do that in JavaScript. The operators are pretty much the same with comparisons, the ands, the ors, the bitwise, the booleans, pretty much like C, actually. And then the control structures, very C-like, pretty much like C. There's a few of them that are not like C. What's like C? The if-else, the switch, identical. The for while, the do while. The for loop's the same, the while, the do while. And here we go. For a variable, for variable in object with object. Different. So we have what we used to have in C, C++, Java, and we've complemented it, actually. And so we have this. This is more, I can't think of the language right now. It's more Pascal-y, actually, but it's kind of an ancient way of doing it. But the JavaScript people assume that you might be a C, C++ language programmer, Java, which you may not be. So if you're not, and you're familiar with other language syntax, you can use this type of, for each. Actually, for each is, I'm thinking about Python, I think is what I'm thinking about. Python does or I think it's Python, does a for each for objects. Don't be afraid of objects. Everything is an object. Object is a definable thing, such as a car, and they allow you to have other objects. A car can have a trunk can have a spare tire. Since JavaScript is an object-oriented language, one of the few scripting languages that's actually object-oriented. You can use the dot syntax as we've seen so far, car, trunk, spare tire, to show that spare tire is part of the trunk, that's part of the class object. And they have attributes and methods, just like they do in Java and C++. Predefined objects are object types, so we could just extend from object. And we can just create a variable and use it like an object too, which is basically what we're doing with this loop. We create a variable object, a variable in the object, and we're just scrolling through the variables in the object. So it's kind of an interesting way of doing it. Using objects, following syntax, same as Java and C++, use the dot notation with the attribute name. So object name dot method name to call methods inside of objects. And an instance. This is a particular incarnation of the object. When you create an object in your JavaScript code, you're creating an instance of it. You can use to represent students, let's say, so class.students, where each instance of the student object would be a different student. So you can have keep track of students this way. And an instance of an object has all of the same attributes of that object. Just like any other programming language, actually. The same concept of creating instances also applies. So in real life, the object is a tangible thing. Wait a minute, this thing we've actually seen already. I think we've seen this slide already. So anyway, yeah, it could be seen like names of objects, talk about them. So we already talked about what an object was, actually. When we use objects, we reference them by their name. And to figure out what it is we want to share. We use programming objects to share information about real-world objects. I don't like that slide either. And then those two slides, I think, are a repeat. I have to edit this lecture, actually. Either that or accidentally put it in or took something out, who knows. Let's look at some information about objects. For example, if we have a green bowling ball that weighs 3 kilograms, we know that the ball color is green and that the shape is round, hopefully, if it's a bowling ball. And the weight is the weight that we've given it, 3 kilograms. So in each of these cases, we have associated an attribute with a piece of data that's describing that attribute. Same thing as we get in regular old languages. So let's figure out how to create an object. So we have variable b-ball, bowling ball, is equal to new object. So we don't create classes. We don't create user-defined objects. It's already done for us. Everything is an object. So we just create variables. And we call them, in this case, we're calling them an instance of an object. We're creating a new object. So we can create an object using a function. In this case, we can create a bowling ball by saying new object. So this code creates a new object called b-ball, bowling ball, the new object function. And then, I don't know if I really want to call it a function, but it really is a function. In JavaScript, it's considered a function. It's called the constructor function because it constructs a new instance of the object. And this is, for those people who are familiar with JavaScript, with Java or C++, you're not going to like this terminology. What it does is essentially it's saying that when you create a new instance of an object, what you're really doing is running the default constructor of the class of the object that you're creating an instance of, which is essentially what this is saying as well. But we always think of objects as more than just a constructor. Anyway, and the whole use of the word new is too Java-like, or too C++-like. But it's the same syntax. It's really not doing anything any differently. It's just all automated for you. Think of it that way. So we don't have a b-ball class created. We just created an instance by saying new object. Everything's an object. So we created this object, and we're gonna use it. So what are we gonna do? We're just gonna automatically just assign values to it. So we're gonna say b-ball.color, shape, weight, holes. Are there holes in the ball? Pre-drilled bowling ball. True. The weight is 3 pounds. It's round. It's blue. So we have the object b-ball. Now we can store information in the object. We can store as much information as we want. So we didn't have to create a class that had variables, data members, member functions. It gets created after the object. Which people who like Java, C++, they don't like this either. It's like, wait a minute. Nothing is predefined. Everything is created after the object instance is created. Now we're going to decide we're going to have color, shape, weight, and holes in there. How are you going to know? Well, the thing is, it's on-the-fly, object-oriented kind of behavior. Nothing was pre-configured ahead of time. We just created a new object. We said, we want the object to have a color, shape, and then we can get at the object. We can say, well, what's the object's color? We can print it out. It's blue. We assigned it to it. So you can store as much information as you want about bowling balls in these objects. So the object information we associate with the properties of the object, with the object using the dot notation. So we associated it this way, saying it's this object color, blue, this object shape, using the dot notation. Allows us to associate the parameters to particular objects themselves. For example, we can easily store the color of multiple different objects using the object name. Will help us keep track of that information. So if we had two BB ball, my BB ball, they would all have different dot colors. And we can keep track of each one of them by a dot color. So we just pick what we want to assign to it and assign it, essentially, as a variable. As a data attribute for that particular object. So here's some examples here. We have bball.color is equal to green, car.color is equal to red. If we were to say document.writeColor, we wouldn't know which color to print. Same thing you get if you do the same thing in any other language. You have to specify, I want car.color, or I want bball.color. So instead we need to reference the object here, which is the same logic that you have to follow with C or C++. The only thing we didn't have to do was create a class and assign these data members to this class. Instead we did it on the fly after we created the object. Which, I wish other languages were like this. See, wouldn't Java be much easier to learn if you didn't have to create these classes? But this is a scripting language that supports object orientation. What a scripting language is, there's no precompiled code. It's a script. So if you're running a script with objects, you're doing it all, just in time while you're running it.
I mean, it's pretty interesting. Object attributes, you can add as many attributes as you want. And it's advisable to keep the number of attributes to a minimum because it gets kind of confusing. Especially if you have like 100 attributes that are assigned to one object, you're going to forget about all the attributes essentially. You should also declare all of the attributes in the same location, making it easier to track them. So all of this stuff together, that way if you start assigning attributes all over the place, it's kind of like when you created functions all over the place and started using them all over the place. It's just hard to keep track of it. And much more the problem with JavaScript than any of the languages, understanding what in the world did the programmer write. Because you're going to see all these, where did this attribute come from? Where did that, reading somebody else's code is a lot more difficult, actually. Primitive types. So now I said we had non-types, but why am I mentioning primitive types? Considering that an object is a new type of variable, we now refer to the ordinary variables as primitive types. Primitive types is one of the regular variables that can be stored. There are 3 different primitive types. Types are numbers, strings, and booleans, which is a lot smaller than you'd think in other languages. And it's just terminology. Anything. You don't have to use those types. You don't have to say something is a boolean. Compound type is an object where you have sets of attributes are all objects. So we have different types or different attributes together. For example, a person object, there might be a name. The name itself might be an object. So we get that compounding coming from inside the object we have another object. Inside that object we have another object. Another object, another object. So we nest the objects in there, which makes them compounded objects. In this case, the object name is the attribute of the object person. Anything of an object of the name, first name, last name would be an object of name. And so we create our hierarchy, actually, sort of like this. So we have person, and then we have name, age, and then name has first, middle, last as an object. So these are sub-objects. So we could say person.name.first is equal to Barbara. And we can kind of, person.age is equal to 21. No, just kidding. I went back a few years. Using compound objects, you can use compound objects in the same way that you use variables. And the advantage of the compact object is your ability to logically manage the objects. So it gives you the ability to, kind of put all your variables together in one spot instead of having person, first name, last name. Going back to that concept of, variables, you can have tons of different variables. If you compound them all together, then you can associate them a little bit easier, abstract, for the abstraction. And you might be able to store all of your related information in a logical object, hopefully. More objects. We have built-in objects that we've been talking about so far. The document object is a compound object. So is the window object. The document object is part of the larger window object. Each of these objects has attributes that can be accessed, as we've seen so far. Here's the window object, the close, which is a Boolean true or false. Location on the screen. History, length, might be a number. It gets stored in the history. And if you go online and you look, you see most 99.9% of all these methods that are part of the object or components of the compound object window are supported by all browsers. But there are some slight differences. And then the behavior slightly varies as well between different web browsers. But because you have to think about it, the web browser is supporting the runtime environment for which the script is being run and interpreted. And for each web browser you have a completely different interpreter. So Chrome is going to work differently than Firefox, than Internet Explorer, because they're written by different people. The behavior is going to be slightly different. There's definitely going to be a lot of similarities for the most part, and your web page should work probably the same, but occasionally you find these really weird logical things that go wrong. And it's not your programming, it's the web browser. So then you tell your customers, you'll have to use Firefox for this. Actually, ITU did that with the EMS. They said, I'm sorry, you got to use Firefox. You can't use Internet Explorer. Or you can use Internet Explorer, but the behavior is going to look different. Because it is.
And it's not the same. It's not just for JavaScript. It's the same for all scripting languages. And whatever language they're using, there's definitely a conflict with Internet Explorer sometimes. The document object. The object is special in the window, and there is no need to specify the parent window object, which is why we keep going document.write. We could go window.document.write, which is really what we're supposed to do. In fact, here we go. Window.document.background color allows us to use document.background color instead. Because that's the special, because everyone goes document. Isn't it kind of redundant to have to go window.document, window.document? And window is assumed, it's the highest level. And then document's a pretty big object underneath window. But you don't have to go window.document. You can go window.something. Open, close. So there are many different document attributes that can be accessed, and here's a couple of them. The document background color, foreground color, URL, last modified. I believe you're going to use this in one of the assignments as well. Link color, viewed link color, all sorts of different things that you can use on that one. So the object methods, so far we've been looking at object attributes, color, weight, stuff like that. We also have methods, same as in other programming languages. The method is a function an object can use to perform various different tasks. And you've already seen an object method write, and the write's associated with the document object. Document object has write. Write method is used to tell the document to print something on the screen, add some information to the page. This is why we see document.write foo, or document.write hello world, for example. So they're powerful for modifying objects. Creating methods for objects that we have created is out of the scope of this particular course. This is not, as I mentioned before, this is HTML and CSS. If we wanted to learn how to create methods and functions, you're going to need more than a lecture or two on JavaScript. It's too time consuming. You do not have to do that for any of the assignments. In fact, you don't even have to program an object orientation for any of the assignments with this, but it might actually come in handy to use some object concepts, because it will make the assignments a lot easier, actually. But it's way beyond creating a function. We'd have to actually get into programming languages, get into actually writing these things. But can take advantage of those methods available to us in the window, the document, and other objects for the purposes of what you're doing for this particular course and your use of JavaScript. Don't need to know how to create a method, but take a full JavaScript course if that's the case. So let's take a look at some of the window objects. The window.confirm method is the object will ask the user a question and get a result either true or false depending upon the button they press. So the confirm is a confirmation box. Okay to continue? Yes or no. Do you want to save? Yes or no. So you can store the result in a question in a variable, and then use the variable later in the program. Okay, save it. Okay, don't save it. So variable question. Question is equal to window.confirm. This is a question where you have to answer okay or cancel. Okay is true, cancel is false. Of course, these aren't really, do you understand? Wouldn't it be nice if all of your dialog boxes were this simple? And if the question, document.write, you understood, else, so if it's true or if it's false, essentially with Boolean logic, else you didn't understand. So instead of checking, and this is the interesting part about writing this type of code, instead of it's already assuming we have two variables, one's an okay and one's a cancel, or we have a yes or a no, and it's working with Boolean logic. So if the question is true, if they said okay, then you understand. If not, then the else says, but we're just checking on the value of here. Is it true? Because true is always going to come back with a confirmation question is always going to come back from a confirmation variable here. This is always going to return true or false, depending upon which button was pressed. So you can kind of see how this is automated a little bit more than, let's say, C or C++ or Java. Window.location. This is that, the screen comes up, says click here to win $2 million, and you put your mouse up and then the window keeps moving away. It's taking a mouse event and it's spacing the window location in correlation 2 inches away from the mouse, so it never actually gets to touch the text. which is kind of funny. Window.location, responsible for telling window to load. Also new websites, but you can also change the location. You know, you can have it so it moves away, moves to a new website. So if you say window.location is, oops, let's put the itu.edu in here, and then it will transport to the ITU homepage. History, actually, the height and the width can also be changed on window as well. And the example I gave you is different from the loading of a web page, but looking at the window properties, the location is going to be the URL that the window is showing in terms of its location, but you can also change the physical location of the window on the screen as well as the height and the width and the, the borders. You can take the window menu off. You can make it a, more of a dialogue looking window. You would do that essentially for help systems, as we saw in another lecture that I gave. History, you can also use the window history to go back to the previous web pages. This is that irritating thing when you say go back. I don't know, websites hardly ever do this anymore, but the big trick was change the history so it's the present page. So you go back and it goes forward. Back. You can never go back. You have to close the window. It won't let you go back to another page because it wants you to stay on their page or something. They're just messing around with the window history is what they're doing, and making the current equal to the last page, which is the page they were on. So example, you want to bring that user back to the page they just derived from. You can use the window history.go -1, take you back. You can do that to your website. That'll make it irritating for me when I look at it. If you load it up on the web, bring them back to one page, so you can go back as many pages as you want. Properties. The object, and this brings up kind of an interesting thing. For every good thing that developers put into a language, there's always some character out there that takes advantage of it. Like the whole concept of cookies and how that was destroyed. And then now the browser history, how that was destroyed. And window location, substituting height and width, making something too small, too big. For a while, people used to make the website so you went to it and expanded out full screen. Because they wanted you to be on their website, and you couldn't minimize the website browser window, which is like, you're stuck there, but not really, actually. Browsers don't allow that anymore. So, properties. The object can have properties. These properties are responsible for identifying and storing information about the object. We've seen that already. These are what's referred to as those attributes or those variables, and it's just putting it into a different vocabulary for you. They're calling them properties. So class.student, each instance of student would have a property called name. As we were saying, we can only access the property by going class.student.name, using the dot notation. And the values, and then we can set the different values for each one of the different objects, different instances of the objects. So we can say class.student.name is equal to Frank. Likewise, we can apply this to the document object, window.document.background color is equal to red. So this is just referred to as properties, the same dot notation, same values, stuff that we've been looking at so far. In terms of accessing those values, we can include an image on our website as an example and give it a name, and then we can access it by the property. This is interesting. So we can say image source is equal to image.jpg. We know that this is HTML code. Name is equal to test pic, and the alternative is like picture. My picture goes here, alternate text for that picture. Now we can access it here. We can say document.testpic, the name. So every single one of our tags elements that we've given a name to, we can get at the name, which is how form checkers work. We can say, call this image here testpic. So we can go testpic.source is equal to image. We'll change the image. Essentially, this is how you could dynamically change. And have a button that says change the image, change the picture. Maybe go through a loop like every 10 minutes it changes a picture or something. And all it does is give this element a name, call it by name, and say the source is equal to this new picture name. And you can do that inside JavaScript really easily. So in terms of accessing the variables, likewise, you can set the background color of the web page to gray using body background is equal to gray. Or you can also access the same property using document.background color is equal to gray. So if you didn't do it,
you know, like maybe up in the header, or I don't know, you did it somewhere, well, you did it in the body section here, you can always just change the background color. If you're reading in, let's say, a preference file that's in a cookie or something, and it said, the user changed the color to this, you can automatically just set the color to whatever's in that file. Events. So in real life, objects can encounter events. An event is some action that has happened. So the window got closed, the window got minimized, the user clicked on something. So you can identify an event that may happen in terms of the web page, and you can watch the event wait for it to happen. So you don't actually have to set up an event listener or anything like that. Kind of like same thing you get in a lot of other programming languages. An example would be to watch where the mouse is placed on the screen. So mouse handlers, or event handlers. So you can see an event happen, and then you handle the event. So if the mouse moves to the left, or the mouse is over something, and we've seen this already in another example with those image maps, where we put the mouse over something, the region of the image, it highlighted that particular region, or it changed something. And we used it for a menu navigation, actually. So such an event is a mouse over. It's already placed an object over the mouse over a particular object in the web page. So the event can be triggered, and an action can occur, changing the picture that the mouse is over or something. And here's an example of our event handler, and it's responsible for doing something when the event actually has happened. So we have mouse over equals document dot background color is equal to green. So when you put the mouse over something, this is text, this is some text, the mouse is going to be over. It's actually going to perform, perform this functionality, which is going to be to change the background color. And we've actually kind of seen this in a couple of examples already, and I think it was in the image map lecture. So it'll change the background color to green when the mouse is over a particular link, which is kind of irritating, I would say. In fact, a lot of the mouse events end up becoming irritating. I kind of like the ones that, you put the mouse over a menu, and it kind of highlights the menu item for you, because then you know which one you're selecting. Because sometimes you don't know, especially if the menu is so small on the screen and the words are so close together, you don't really know which one you're hovering over. I'm trying to pick the right one, so it kind of gives you confirmation that this is the one that you've selected. On a mouse out event, you can also make things happen when the mouse moves out or it gets removed from an object, when the mouse moves over a picture. It's also known as the on mouse out, and it works the same way as the mouse over. In terms of variables, we've seen some of the variables used in sample programs already. We can set the value of the variable to whatever we want. We can use the variable whenever we want to use it, and it can be reused as many times as we want in the program. And the concept of it is essentially very handy, especially in terms of being able to create like a global variable, have a function change the variable, have other things happen to it. And JavaScript supports the concept of arrays. So an array is just an ordered collection of data, and we create a new array, kind of like the same, array is a form of an object actually, and it is an object, because everything, even variables, are objects. So here, instead of saying new object, we're saying new array. It's a new array type object. And what we're going to do with this object orientation, and what you can do, is use all the built-in object types. So you don't actually have to create your own object type. So if you want to store 10 pieces of similar information in an array, easier to come up with 10 unique variable names. It's easier than doing 10 unique variable names. Arrays are indexed by a number starting with 0, just like they are in other programming languages. So we have variable pets. We didn't give it a data type, we just said variable, same way we've been doing so far, is equal to new array. Pets 0 is equal to Fluffy, pets 1 is equal to Sparky, and then we can have as many pets as we want in this array. We didn't actually give it a number. We didn't set the size of the array. It grew dynamically, which is kind of different. So arrays usually start with 0 and go from there. And some programmers like to start their arrays with 1, as they believe this is a normal, natural way of counting, easier to understand. So as long as you are consistent, it doesn't really matter. It doesn't make a difference. Although I do prefer to start arrays with 0. You can actually start it with 1. It just means the 0 is always blank. Because
we didn't have to say 0. We could have just said 1, 2. And then we don't have to worry about array indexes. We don't have to worry about how many items we put in this array either, which is interesting. So methods that we can do, in terms of objects, and this is more terminology for you again. We've seen this already. These have been called functions, methods. Methods are actions that we're going to associate with each object, and each object, like the array, has actually different methods that can be run on it. So the actions are often triggered by events, called by in the middle of the program. So as an example document, object has a method write, which we've seen so far, write text. Function is a group of statements that have been collected together to perform a specific task. Functions are grouped in a way that they can be reused many different times in a single program. And we call the function in the same way as we call a method, just by using the function name. And we've seen that already, actually, in a couple of different examples. So let's look at methods that are associated with the array object. Because we've looked at a document object a little bit so far. Arrays are supported as objects. So the attribute length is going to return, the name, or excuse me, the length, how many items are going to be in the array object. Methods might also include concat, join, pop, push, reverse, sorts, which is cool because now it's an array object, so we can have built-in support for a lot of different things that we don't normally have in other programming languages. So here's an array example. We have an array A, which is full of 1, 2, 3, 4 numbers. And then we say, for I is equal to 0, I is less than A.length, run the length method, or actually the length variable we're getting in terms, and then I plus plus, AI plus equal to, and then B is equal to A.reverse. So we run the method reverse. We get a sort, it'll sort in alphabetical order. We could reverse sort it. You can go online and look up all the different array methods that exist. You'll be amazed how many different things you can do in an array. Many other predefined object types outside of the array type. And the string is a good example of one. The math, the date, for date conversions, regular expressions, numbers, limits, conversions to strings. Everything comes in by default as a string, however. Then it gets parsed to an integer or to a float or to a number of some sort. In terms of our predefined object, JavaScript also includes some objects that are automatically created for you. And this would be the document that we've seen so far, the window. We have the screen. We also have the navigator in terms of the buttons for forward, backwards, and stuff like that. So in terms of the document object, many of the different attributes, and this is just a small list actually. These are the ones that are commonly used. You can go online again. Actually, nobody ever memorizes how many methods there are to the object array, how many methods there are to an object of a date. And the interesting thing is you can find out which these other predefined object types are, create instances of variables that are of these object types and run them. So you have dates, times, arrays, all sorts of different things without actually having to create the object types. They're built-in object types. It'd be nice if Java, well actually Java does have some built-in object types. We have a lot of the lists objects, stuff like that. And a lot of the packages as well. So here of the object type, of the object attributes, the title we've seen so far, URLs, forms, colors. We just create a form object, links, images, refer, where this object came from, stuff like that. In terms of the object method, the object write, like a print method, the object goes into the HTML document here, and this plus will do string concatenation of the object title. So we can put together an object, and this is an example showing you that inside of the write we can actually run a method on the document itself. So, hello. Oh, there we go. And here is our JavaScript example. This is the hello world mixed in. So now we got JavaScript mixed in with HTML code. All putting the pieces together here, kind of coming to a conclusion eventually here. So we have head, section, title, JavaScript is fun. I'm a web page, JavaScript.write, document.title. So it's automatically put into the script here. And this is all in a head section. This is in the body section actually, in between the script. So when we say we're going to use a script, we actually have to kind of, say open tag for a script, close tag for a script, use the JavaScript. And here is JavaScript and the HTML commands put together. And so we can put in comments. See, these are HTML styled comments that are going to be in terms of the script. And so when we want to use it, we just take the comments out and the code will actually run. So anything inside of HTML, anything inside of the comments is not going to be executable. In terms of the function, here's what one looks like. Just like we used a variable var to declare a new variable, we can use function, the word function, add x and x comma y, and return x plus y. So the keyword function is used to define the function or the subroutine. So it's kind of simple. We don't have data types to worry about, which is kind of interesting. In terms of the Java events, it supports the event handler system, so you can tell the browser to execute JavaScript commands when some event actually occurs. Sometimes resulting value of a command determines the browser action, close the browser, open the browser, navigate to another page or something. Here's a simple event example. And we actually looked at this already, the onload and the onunload. On the onload, run a restore the background color of the web browser. So the background color is going to be equal to white. Clone a very small page, and we're going to save the width. And here's what I was talking about before. We can actually set the location in terms of the coordinates on the screen. We can also set the width and the height of the browser. So, you come up and you have this itsy bitsy little browser window that shows up, and then when you close that window, it restores the browser setting. This is kind of a nice feature they put in here, actually, because some other people don't do it, and nothing ever gets restored back on an unload. So have you ever gone to a page and seen it was resized, and then you go to another page and the other page is still inside this resized window, and you got to fix the window manually. It's kind of irritating. So if you don't want to irritate your users on the unload, you can have a restore function, and the restore function's right here, function restore, where it's going to put it back to the original because you're saving the window inner width and the inner height. So you're saving the height and the width, and you're going to restore it back. So change the window size to be small, and then change it back. And here's the background color to cyan instead of white. So we changed it to 50. Actually, half the size looks like 300 by 50 or something. Buttons, as we've seen so far, you can associate buttons with JavaScript events. So we have buttons here. And the input type is a button. We've seen this already. The value is don't press me on the click alert. Now you're in big trouble because you pressed me. So this is an on-click event that occurred. So we've actually seen examples of buttons when we looked at forms. So some events, small sample of some events. The on-load, the on-unload we've seen already. The on-click, we've actually seen that already. We haven't really seen the mouse up, the mouse down event, or on double-click, or on mouse over. So, nice song. Is that Ice? Document object model. So naming the history used to access individual elements of the HTML document. This is where we have the DOM. This is what the acronym actually stands for. It's called the Document Object Model. A little different than the Netscape DOM is a little different than the IE DOM, and this is something that's it's not exactly standardized, but it should be. So it's easy to use if you name all of the entities, forms, fields, images, etc. So in terms of the naming hierarchy. So Document Object Model, more terminology for you. And here's an example of that. With the form ID, so my form action, please enter your name. We have a text field, input field that's going to take the name, and it's going to have the ID is going to be age, the name is going to be age. And enter your weight. Anyway, so the JavaScript can get at the form input as going document.myform.age.value. This is what's referred to as the document object model, meaning you're putting object names and you're accessing the object names or the object elements inside of the window, which is inside of, inside a document, which is inside of the window. So, form field validation. Lo and behold, as promised, here's an example. The most commonly used JavaScript functions. So you can have JavaScript code that makes sure that the users have entered in the right information. So when your submit button is pressed, it will check all of the values of the necessary fields, so you can prevent the user from entering in the wrong information. So here's how you would check a form. So checking fields. This function called check form you're going to create, and in here you're going to go document.myform.age.value. If it equals to 0, it's empty. It means I left out your age. Put a little alert here. You didn't specify any age. And then return false, else return true. Needs to return true or false. Needs to return true or false to come out whether see if it's validated or not validated. Because then you check, is it false? Yes, it's false. Go back, reload the page, highlight the label in red, put a little asterisk next to it, and then everything else is grayed out. And it says enter in your age. The most common use for JavaScript. Why? Because it's right there on the client's computer, taking up the client's resources, not the server. Checks it before it even makes it to the server, which is great because it guarantees hopefully you've got good code, or good variables, values and things that are being sent to a server, if that's the case. So you can use JavaScript to do the form checking, and you can go online and you can see millions and millions of JavaScript form checkers that are all free that you can put on your website to check the content. And it's free because no one would pay for this actually, because everyone can put it together. It's not that hard. But some of them are pretty useful actually, pre-written. So you need to prevent the browser from submitting here. And this is why we have the return. So if it comes out to true, we're testing it. See on submit equals return. That one is going to be true or false. And then if it's false, then it's going to do something else. And if it's true, it's going to put it through. So, important note about form validation: it's a good idea to make sure the form has actually been filled out before it's submitted. Users can bypass your form. They can create requests manually on their own forms. Decision making in code. We're actually almost dead. Don't worry about it. So I'm going to give you the entire lecture today on this. In terms of the outline of what decision making we have to do, we've seen everything else. We've seen functions, we've seen objects, we've seen variables and how that's being used. Now we need flow control, which is our decision making. We have Boolean variables, how to compare the values, the if structure, the if-else structure is pretty much what we're working with. And it actually supports the switch case as well. But if-else is probably easier to use in most cases. In terms of the Boolean variables, these are the variable that is able to hold a true or false value, like any other language. And it's used to answer simple questions, and we actually saw it in that last example where we said on submit, and that function call is going to return true or false. So if it's going to be true, we're going to do something. So if the answer is true, do something. If it's false, do something else, essentially. In creating the Boolean, here's how we would do it. We would say variable x is equal to false, because x can be a Boolean. You can store x. And this means that x will store the value of false. Note, it's not a string. It's not a number. It's Boolean. So it automatically gets assigned a Boolean value, just the same way as it automatically got assigned a string when we assigned it a string. False is one of those key words here, and you notice we didn't actually put quotation marks around it. We just put the word false in there. If we put quotation marks, it would be stored as a string. If we put a number in there with quotation marks, it would be stored as a string. If we put a number without quotation marks, it gets stored as a number. And true and false gets stored as a Boolean. In terms of comparing values, we can compare the two values together. We can determine what the relationship is between the two values. And we can do that by assuming that we have, let's say, 3 variables in this particular example, x, y, and z. And we can say z is equal to, well, is x smaller than y, true or false? So then if it is, then it would be true. If it's not, it would be false. So we can say that z is false or true. And then comparing the values, and actually that's kind of, same kind of similar logic that we have in other languages, but most other languages don't actually truly support Boolean values, but majority of the popular ones, Java, C++, C, do, so it's very similar. In terms of the comparing the values, we can compare 2 different types of ways here. The less than or equal to, the greater than or equal to, the equals, the not equals to. That should look familiar. It's just the same as other programming languages. In terms of the example here, if x is equal to 2, y is equal to 3, then if we say, z is equal to, z will be true, false. So we kind of work through the logic and sort of see how that gets put together. In terms of comparing strings, we can use this string equals comparison operator. Same thing we do in C or C++ in Java to compare two strings. Actually, you can't do that in C++. You have to use a method on the string object to actually do the comparison. So here you can check to see if the two strings are equal. Name 1 is Bob, name 2 is Fred. The result is equal to, is the name equal, first name is equal to last name, or is the first name not equal, excuse me, is name 1 not equal to name 2, vice versa. So. Logical operators also supported, noting that you'll be able to work with Boolean variables. You need to be able to work and deal with multiple Booleans. So you can need to make multiple comparisons and then decide based upon the results what to do. It might require some logical operations. And that would be the and, the or the not. So is this and this true? Is that or that true? And that will actually determine your flow control. Operations can be used on any two Boolean variables, which is on a Boolean value itself. So it comes back and says, if this and this, if they're both true, then it's true. One of them's true, the other one's false, and it's an and it's going to be false. So, just the same as other programming languages. In terms of the and logic table, true and true is true, true and false, false, false and true, false, false and false, false. Although there's some languages that take false and false and make it true. But no, the standard approach is it's false. Or the or, true and true, true, true or false, true, and one of them has to be true. False or true, true, false, 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 not true. So putting it all together, the logical tables require two Booleans. Since any comparison that we make results in a Boolean, we can use these comparisons in the logic, to create the logic that we need. And they have to, essentially make a decision for us in terms of the flow control. And we can take the same, and the Boolean concept actually is the same as in other programming languages. And we combine that with an if-else-then statement, or if-else, and we all of a sudden have flow control. So one key decision making is the if statement, and allows us to determine if the value of the Booleans, and based on the particular value, then execute some code, otherwise skip to some other code and do something else. So the easiest way to control the code, here's how it works. If Boolean expression, if it comes to true, do something. And then we can add an else to it. So here is an example of variable number. Number is equal to prompt enter a number. If the number is less than 10, your number is less than 10. If not, it's greater than 10. So just think of it true as an if. The if as true, and then the if as false is the opposite in terms of the if else, or the if, and what happens if the if doesn't execute. Here's another example. In terms of, or this is just an explanation of the example. The number is less than 10, you're going to get a response. The number is greater than 10, you're going to get a response. If the number is equal to 10, what happens? Nothing. It doesn't meet either one of those two criteria. Uh-oh. So if-else structure, which is why you probably want to use an else with that. So the if-else structure is similar to an if structure, except that second part is associated with it. The else part catches all of the cases that are not associated with the if. So if something happens to it, it allows you to cover two different cases in the same structure. So if-else structure, here we have if some statement, else some other statement. So if comes out false, then do something else. You can also nest as well. You can nest ifs, else inside, just like other programming languages. So here we have the same example as before, but we have the else in here. So if it's not smaller than 10, then it's going to be printed out if it's equal. More on the if. The if and the if-else statements are the building blocks, essentially, for decision making. And they can be used to control the flow, and they can be executed. And if it's not executed, they're going to be skipped. So the code doesn't make it through it. If the if condition doesn't exist, it's going to bypass it. And allows users information to affect how the program is going to be acting. Some possible problems that might exist. One key problem when dealing with the variables is making sure that you're comparing what you want to compare. So comparing the wrong variables might be an issue. From the perspective of the user entering the input, you should be careful that what the user enters in is the correct information, and what you're comparing is the same thing that the user entered in, which is interesting. Trying to compare numbers that the user enters in as letters is going to be a problem. It could cause trouble. So it's a string, but you're trying to compare it to a number. It's going to be an issue. So here's an example. If you try to compare a number entered by a user, but the user enters a string, then the comparison will still happen. And because it's not going to check to see, oh, it's not a number, it's a string. It doesn't do any type checking. So it's going to compare whatever it is you tell it to compare. So you might want to use a number entered in by the user later, but because it's a string, it will cause an error. So your result will not turn out to be what you want it to be. It's going to turn out to something else. In terms of checking the input, this is actually kind of a useful trick to do. You can check the input from the user with the function is not a number. And the function allows you to determine if the parameter is not a number, if it's a string. If it's anything but a number, a boolean, a string, or something. So now you can determine if the value is a number, and then you may ask the user to re-enter the information if it's not a number. And here's an example of how to use it. Variable number test. I've got two variables going on here. Numbers prompt, enter a number. Test is equal, is not a number number? So did they enter a number or did they enter text? And you can do this in your forms as well. If test is true, the input was a string, else it's a number. So we're testing it. Is it not a number? If it's not a number, then it's a string, or hopefully. What about bad input? If you receive bad input from a user, you can warn them that the input is bad or incorrect with an alert box. Otherwise, what ends up happening is the browser is going to take that alert box and cancel it, disable it, so the user will never see the alert box. So the alert box will create as a pop-up dialog along with the same text. The box will stay on the screen until you click OK, if the browser actually allows the alert box to occur. One way to give users any information. So here's an alert box. We've seen the alert boxes already, actually. Some browsers disable it. So for the purposes of the assignments for this class, you can use alert boxes because my browsers have them all turned on. So I can accept an alert box. But sometimes when you test it, it's like nothing happens because your browser security has turned off the alert boxes. That is the end. And most of you are sitting here going, when is she going to end? That is the end. And we are done for today. That is everything you ever wanted to know about JavaScript. And believe it or not, outside of creating your own objects, which you don't need to do for this course, then that's all you have to worry about. This is the entire. That's a pretty easy language. It's not like learning Java, C++. It's a scripting language. It's one of the easiest languages to learn. If you just remember, it breaks all of the object rules. It breaks all of the type rules. It doesn't work the same way as a traditional programming language does. Everything's an object, even if it's a variable. And you could just create attributes for objects that don't exist and use them in the object. So once you get a feel for it, you'll end up struggling when you go back to writing Java and C++ code, because you'll be like, wait a minute, this is harder. So, questions? If you missed the beginning of the course, for those people at home watching this video, you can turn it off right now. People who are taking this course, who are interested in the final exam schedule, all students, all times, from 9 o'clock a.m. to 5 o'clock p.m. No groups assigned this time. So you don't have to worry about the first character of your last name in the group time, because everybody switched them anyway last term. It didn't work. So between the hours of 9 a.m. and 5 p.m. I will be offering the final exams. And I will be offering them on these particular days. These are the days in which you should show up to take exams. However, if you have two classes and you want to take both at the same time, go for it. We're going to have all of them here. So you can come in on Monday the 8th and take the exam for this class. And then if you're also in the Unix class, you could take that one as well. Or you could skip Monday the 8th and come in on Monday the 15th and take the HTML exam during the Unix time slot. Or, if you like Wednesdays, most people who come to class on Mondays like Mondays because you're here, which is probably when you're going to show up. I would prefer that you showed up during these times, but you don't have to get pre-approved. You don't have to get approval to take multiple exams at the same time. Or if you want to come in on Wednesday the 17th, not advisable, but you could come in and take all of them. Only problem is you're going to have everybody else doing the same thing probably, and it's going to be crowded. It's kind of like waiting till the end of the term to upload your assignments into the EMS. And the EMS goes down. Kind of the same concept. Here you're going to have to wait in line because the room's going to be full. You're not going to be able to take the exam. So this is the recommended schedule. And this is when I'll be promoting, I'll be putting this out on the website as well. But for you guys listening to this, know that you can hop around any one of the times. And Monday 8/8 is actually in a couple weeks from now. It is not next week. The 8th, today is the, what is today? The 18th. Next week's the 25th, and then we have the 1st. Well, we have 1 more, 2 more, 3 more class meetings. Then we have the final exam starting. 2 more? Did I count this wrong? 25th, 1st. Oh, 2 more. 2 more class meetings. Then we have the final exam week. That starts on the 8th. Or it starts on the 15th, depending upon when you're going to take your exams. Questions, comments, concerns? Because everyone's been asking me, when are final exams going to be? I'm telling you, this is when they're going to be. All the formats will be multiple choice on all of the different exams. They will all take you between 1 hour and 2 hours each. They will be closed book, closed note, closed internet, closed neighbor. And I guess next week. Do I have 2 weeks left? Okay, not next week, but the following week. The week of the first week, this week here, I will be doing final exam reviews in each one of the classes. So next week, I'm going to finish, for this particular class, next meeting, I'm going to finish up JavaScript and then concentrate on giving you help for those assignments. And then you should be able to do all the assignments are due on the 16th, Tuesday, 20th. Most likely the due date will be extended out to the 20th. Shoot for the 16th. But next week we'll be focusing on 1 more lecture on JavaScript stuff. Finish that stuff out. I covered most of JavaScript today that you need to know. But next week we'll also be going over all of the assignments. So if you have questions or doubts about the assignments, next week is when I'm going to be answering all those questions and helping you. Basically give you resources to find out and go through details on what you're expected to do for each one of the assignments. Questions, comments, concerns? Nope, never have any. Good, we're done. Bye, see you next week.